Hello, my name is Jon Hall, and I'm the Laser Product Manager for Domino North America. In our last video, we discussed power concentration. But while power concentration is absolutely critical, it's not the only factor that we need to consider to get good marking performance. It's equally important to understand the characteristics of the material being marked. In order to achieve good marking performance, the wavelength of the laser must be well aligned with the absorptive characteristics of the material being marked. This can be especially evident in carton marking. In this example, you will see two carton materials which appear identical to the human eye. However, when marked with the same exact laser settings, the results on the two materials are dramatically different. And this is a topic that we're going to explore in more detail. I'm pleased to have with us today Dr. Stefan Stadler. He runs our application labs in Germany and is also our team leader at our Laser Academy. Dr. Stadler, could you help us understand more of the critical factors in laser coating?
Coating with CO2 lasers is a pure thermal effect, which means that we are utilizing the energy of light waves to heat up materials. So waves are all around us, and the property that actually determines what waves are doing with matter is the so-called wavelength. The temperature actually is proportional to two factors. One of the factors is power concentration, and the other factor is something we call absorption. Since we are coating with light, we have to ask ourselves which property of the light actually determines how matter interacts with light. We call this region the mid-infrared, and we have three different kinds of lasers, which we call the red tube, the black tube, and the blue tube, and every laser has its own fixed wavelength.
That's exactly right, Stefan, because wavelength determines how energy interacts with matter. And for CO2 marking, it's all about elevating the temperature to create contrast in the substrate. At Domino, we have state-of-the-art equipment and techniques to determine the composition and the absorption characteristics of the various materials. So let's look at some of these unique material profiles, unique fingerprints, if you will.
What you can see here is the scan of a PET water bottle. And you can see in the curves that we have a number of peaks and valleys. The peaks we could call hot spots, because if we were able to find a wavelength which we could irradiate the material so that it actually matches one of the hot spots, the PET bottle would get very hot at this point. In the valleys, on the other hand side, we call it the cold spots, because if we irradiate the material, the PET bottle, with a laser wavelength which actually matches one of the valleys, the material would stay cold and we would get a very poor or no effect at all. We have an independent study which certifies that the barrier properties of the PET bottle, if we are using our blue tube lasers, are completely unharmed. This is not surprising because the depth of the laser etching is only 5 microns compared to the 200 microns of the PET bottle itself. Similar to PET, there are many other packaging material like polyethylene, polypropylene, cardboard materials, which all have their unique fingerprints. They all have hot spots and cold spots, but the location of the hot spots and cold spots are completely different from material to material. Let's talk about cardboard materials, for example. Cardboard materials may look all the same to you, but as you can see from the fingerprints, they are all different. A perfect example is if you compare coding 2 lines of text on a pizza box on the one hand side and putting a 2D matrix code or other machine-readable codes on a pharmaceutical carton. Obviously, the pizza box carton is read by the human eye, but the pharmaceutical carton is read by a camera system, and if the quality is not good enough, then you simply have very high rejection rates, what you do not want.
Historically, and typically still in most sample labs today, the laser coating process is still one of trial and error. It's time for a more scientific approach. With the technology and the tools that we have at Domino, we are able to take the guesswork out of your application and deliver the right solution for your application. I'd like to thank our guest, Dr. Stadler, for being with us and providing expertise on how important wavelength is to your coating application. I'm Jon Hall with Domino North America.